In this video, I'm going to show you how to use the Bridge Design software. So you should have already had it downloaded at this point. So go to your bottom search bar and just type in Bridge and fire up the program. When you fire it up, you can either create a brand new design or load a sample. For now, we're going to load a sample. And here are some templates or samples you can use. We're not really doing suspension bridges in this class. We're going to do a truss. So we have one truss design where the truck rides on top of the truss, and then over here the truck rides on the bottom of the truss. We'll do that one for now. And here you have the default where each node is shown, and then each member is also shown, and then listed here you have members 1 through 19. It tells you its length of the member, its slenderness, which we don't really talk too much about slenderness, but slenderness is kind of like the ratio of its length to width type thing. And if it's too long for how thick it is, then it'll fail for that reason. The material is carbon steel. The cross section is solid bar or hollow. The size is like the thickness, and then the length is the span. And from here, you're able to kind of edit things as you want. You can add more nodes, add more members, click something to select it, and then delete certain things. So let's just kind of add a few more nodes just to kind of practice doing that. And then if you want to select something to see it highlighted, you can click it, and then you'll see where it appears on here. And if you want to delete something, you can just click. Why is that not deleted? Well, if you want to delete something, you can click on it and then hit delete. Okay. Then when you want to go test it, you can go over to test and then load test. And by default, these ones are going to work. But the cost is relatively high based on the parameters of this assignment. So this would cost $287,000. So we're going to go test, then back to drawing board. And once you test it once, you'll notice that these two columns now populate. And it'll tell you values based on its force to strength ratio, or compression force or tension force to strength ratio. And you'll notice each one of these is either tension or compression. Blue for, I think it's blue for tension and then red for compression, but I'm not positive. And you'll notice that each one of these only has one of them. And basically, you want a ratio of force to strength to be as close to possible as 1. Because if it's less than 1, that means that your member is way stronger than the load being applied, which you might think, well, that's good, right? Yes, it means that your bridge is not going to fail, but if a member is way thicker than it needs to be, you're wasting material. So one way to quickly save on material, you can kind of click the first one, then hit shift and click the last one to highlight all of them. Let's see what happens when we make them hollow. Watch what that will do to the price up here. All right, so we just dropped it pretty significantly. And let's test it again. Already the bridge isn't doing too hot. And we fail. Okay, so let's go back to our drawing board and look. It tells us exactly which ones fail. And it will fail if the force to strength ratio is greater than 1. And it'll actually make it fail if it is 1, since they want it to be stronger than it is experiencing force. So if that ever happens, let's look at member 6. So when you click on 6, it kind of highlights over here. We need to make that a little bit bigger. Now 1.08 is pretty close, so we can go ahead and make that a little bit larger. And we can keep testing it and kind of isolate it and solve it one at a time. So let's see if doing that will still probably fail. Let's see if the member that we just changed will fail. Okay, so now member 6 is good. Now we jump over to member 8 and member 9, and they're symmetrical, so what we do to the one, we should do to the other while we're here. Let's make that a little bit bigger. And we'll test it again, kind of isolate those problems. Okay, and it still failed, but much closer now, so we'll make it the next size up. And I imagine that would work. Okay? And by work, I meant 8 and 9 will work. And we have one more, and that's barely failing because it wants it to be less than 1. So the next size up will. And now it works. Now we're not done yet. We just have a working bridge using hollow bars. Anything that's going to have a really low compression force to strength or tension force to strength ratio means that we are using way too much material. So something like this, we're going to actually want to reduce the size of it. So 0.35, that's really low. What if we drop it down to that? We still worked and we reduced material. So now we're at 0.62. And now we're going to drop it a little bit more. And you're going to try to minimize how much material you are using to minimize the overall cost of the bridge. So the goal of whatever assignment I end up giving you will be to create a functioning bridge that uses that costs the least amount possible. And that's kind of the gist of it. We'll end it there for now.